By the end of today's video, you'll have a complete understanding of what a RAG agent is, and you would have a completely built RAG agent yourself in your n8n. So jumping right in, this is what a RAG agent looks like. First of all, no need to get intimidated or overwhelmed. Let's take it one step by step. So first, what a RAG agent is. Let us get to know what actually a RAG is. So RAG stands for Retrieval Augmented Generation. It is nothing but you asking something to an LLM or a database through your query, and it not having all the knowledge in itself, but going and it is retrieving the required answer from a pool of knowledge, a database or a stored memory, and retrieving it and answering your query based on the knowledge it has retrieved. That is basically that. Some people tie RAG with only vector databases and all. No, the RAG is nothing but an intermediary pulling uh, knowledge from a knowledge pool or stored memory and answering your query based on it. So in a RAG, first of all, the first process that involves is ingestion. Whatever database or whatever stored knowledge pool you're having, getting all your like documents, images, or whatever you want your RAG agent to have knowledge of, you first ingested into its memory uh, in another vector database. In n8n, what we do is we use a vector database. Uh, I'll also explain what vector database is. In a vector database, you ingest all your documents and you attach that to an AI. So, what the process of ingestion looks like? Suppose you have a lot of documents, maybe hundreds of documents and thousands of documents, and this extends to a lot of data. But if you attach all the documents to an AI and you ask it to answer it, like if you attach a document of 100 pages and you just can't attach everything in one prompt to an agent and ask it to answer based on that. And that will also, after a few messages, it will lose the context of the message, and finding the exact answer you want in that such a huge document is also a really tedious task for the agent. So what we do is we break the documents down. We break it down. Sorry, we break it down into chunks. We break the documents down into small manageable pieces. This chunking process can happen can be defined by you. If you want to chunk every 200 words, every paragraph, or every chapter, it basically depends on what your use case is. Then after you have uh, divided your documents or your knowledge, whatever you have, into chunks, there's an embeddings model. This is a large language model which takes your chunk and rates it uh, on a on a high dimensional space. For example, let's zoom out a bit and look at an example. Suppose you have all of these cars and you are judging them and rating them on basis of and different properties. Suppose you're ju- suppose you're judging them based on being red in color. So suppose you have red. So first car will get a 10 out of 10 because it actually is a red car. So you get 10. Second one is not a red car, so it will get a 0. Then third car, it is also not a red car, so it will get a 0. This goes on and for every car. And suppose there is a car which is kind of red and like it is maroonish in color. So what you do is you give a different rating, like 7 or something. This way you give rating to each and every single car in big red. Suppose you give it height, ride height, or we can say ground clearance. So what you do is give it height. Based on height, if you just, this will get a really, this first car will get a really low score, basically a 3. And if you go into the sports cars, these will get even lower rating, like maybe 1. But if you go into SUVs and all, you'll get 7s, 8s, and you judge on these properties. And suppose if I just, from this table, I have whatever data I have said, if I ask you, what are the cars which are above 7 and above in ground clearance or height, there's a high chance you'll get all the SUVs, right? The same thing. What you do is, from by giving it by judging them on different properties and scoring them on different properties, you can select out these cars by some properties and by your query. Okay, if you say SUV, what the LLM will do is go ahead and look at this table and look at it with height more than 7 and above. So it will get you all the SUVs. Just like that, when you have a chunk, what you do is, the LLM, what it does is, it rates it on different properties. It checks on the actual meaning and uh, semanticness of the chunk, and it understands it and rates it on different dimensions. But the thing is, here we took a small example of how many dimensions. We just wrote the properties in which we put in this table are called dimensions, basically judging on different dimensions. So what an LLM does here in embedding the chunks in the vector database, it rates this chunk on different properties, different dimensions. And it not only rates it on like 2, 3, 4 dimensions, it rates it on hundreds of dimensions. Usually the industry uh, baseline is almost 700 dimensions. So baseline starts from 700. The Google embedding model starts from 768 something, and open AIs and other embedding models start for like 1500 dimensions. So you get so the agent which will retrieve the data will have the exact idea of what this chunk is, because it has a rating of what it is describing in every dimension. So just like that. So the embeddings model rates them on a lot of dimensions. If you consider it just 3 dimensions for the examples, the chunk gets placed in that dimension based on its score in the space, vector space. Then this is the whole ingestion process. Your files getting inside your vector database. And this is the vector database in which all the chunks are placed on the basis of their properties. Then there's retrieval. In retrieval, you ask a query, and the embedding model, what it does is, it chunks and it embeds your query as well. All these chunks inside the vector database are called embeddings. So it also embeds your query inside it, and it ranks your query, the words of your query, in all the dimensions, and it places it inside the vector database. Now, what all the embeddings are nearest to your query are returned to your AI agent, and you get your answer from these, because they are really similar to your query. So if you said what are the SUVs and you put it here, it basically runs on what words you have. Like SUV, that means height should be 7 and above. So it ranks on height. If suppose this is the height dimension and it tracks 7 here, so your query gets embedded here, and the nearest chunks are all the SUVs. It retrieves that and passes to the agent, and the agent understands and gives you the answer. So let's look at the actual RAG agent. First of all, the pipeline. Pipeline is nothing but the ingestion process, is basically getting your data inside the vector database. So I have a pipeline here that runs every day at midnight. Every day at midnight, it goes first and it scans a folder in my Google Drive and gets all the files that are present in that Google Drive. So if I execute step here, and you can see in my drive, I have these many files. You'll get the ID of the file and the name of the file. See, these are all the files that are in my drive. folder currently. Then it goes and it retrieves all the rows in a sheet. In the sheet, what I have put is all the files that have already been ingested and put inside your vector database already. So these are the files that have already been ingested, and they're marked as done in this sheet. Then we have a merge node. What this does is basically just concatenates the data and like puts together the data from these two nodes. Then you have the code node in JavaScript. What this node does, it filters out the documents which have already been processed and only passes forward the documents which are yet to be processed and needs to be processed and put inside the vector database. So next, if you whatever amount of files, if you have more than like one file, two files, three files, 10 files, hundreds of files, what this next node will do is it will loop this, it will loop over it, and it will run this whole loop once for every file. So after this, you download the file, the basic node of Google Drive downloading the file. Then for now, you can ignore these two nodes. These are regarding metadata. You can just directly connect this to here, and after disconnecting this, this is your Superbase vector store, where Superbase is the vector database provider we'll be using. So I have here connected a Superbase vector database. So you can just do it as well. You can just copy the guide, and there are already videos. I'll also be making a video regarding Superbase, connecting your Superbase to your n8n. So you just add a Superbase vector store, and you give it access to the vector table which you have created. And you can also define how big your chunking you want it to be. In here, default data loader will add the file, we'll get the file in here, and then we'll have an embedding model. This is the model which will embed all the chunks into our vector database. At the end, it will go into a sheet, and after it has been ingested into your document, into your vector database, it will mark it as it has been done and it has been processed in your Google Sheet. So if we run this workflow once, it gets the drive link, and it is currently downloading one file which has not been yet ingested. It's going to the vector store, and it is ingesting it into the vector database. And after it, this is marking the sheet and done. The file has been ingested. If we go back into Superbase vector store, vector database, and reload our table, sorry, this is the one. This is the vector database, and we see here we have all the document has been broken down into many pieces, and it has been added to our database, vector database. Now going back to our your files are now done, and this is basically 90% of the work done. The next is your actual RAG. You can connect it via chat, and we'll just chat right here. So this is you just basic RAG agent connected to your vector store, because you obviously need to retrieve it. So the vector data store is added as a tool for this AI agent, and I have added Postgres chat memory. You can also add simple memory. This works fine, and any chat model. For this purpose, we'll connect this to a Google chat model. 2.5 flashes for it. So this is our RAG agent. So let's chat. So the document I have just enlisted is for a mock company, mock data which I just produced with Claude. So a dummy company called TechFlow Solutions. It is a SaaS company. So let's ask it questions. Let's ask, hello, what can you do? I can help you by looking up documents and information about TechFlow Limited. Just tell me what you're looking for. So we can ask it about a lot of stuff. So first, let's ask about Let's ask it about our mobile application. So go, tell me about your mobile app. Say it went and it hit the vector store and it gave us the reply. The Taskmaster Pro mobile app is available on iOS, and it basically gave all the details of what it was listed on in the document, the exact details. It went and it retrieved from the vector database. Now let's see what actually happened behind the scenes. Our prompt went to the AI agent, then it got saved to the memory, then it went to the Gemini model, then the Gemini chat model, what it did was send a query to the vector store. The query was sent as mobile app. Then the vector database, it returned one, two, three, four chunks. So it returned four of the chunks from our vector database, and it basically what it did was take our query mobile app, and it also embedded that inside our vector database and see which chunks were the closest to it and return the chunks which were closest. So what our chat model got was these four chunks of data, and based on these four chunks of data, our model replied with this all of this. It took all this data and curated a reply, and this is what we saw at the end. At the end, everything was saved inside the chat memory. So this is basically your RAG, retrieval augmented generation. There are many ways to also enrich your output, what you get from the RAG. There's metadata, re-ranking. There's a lot of stuff that goes to enhance and make your output better in the RAG agent. But basically, this is the idea. And if you want another video in which you want me to explain how we can add metadata or re-ranking inside your vector database, because when your vector database gets really big and really huge with hundreds of documents and maybe gigabytes of data, then what you do is you add a lot of these techniques like re-ranking, metadata, hybrid search, all these things that enhances your output, what you get from the RAG agent. So that is it. See you in the next video. Peace out.